My name is Bob Baxter. I'm with Technical and Business Systems. I'm a principal with the company, and we do environmental research and look for different options and opportunities for collecting air quality and meteorology data. And what we have here today is one of the new platforms that we're developing. It's what I call a UAV, an unmanned aerial vehicle, and it's a very versatile platform for doing collections. And we're looking at the types of sensors that are available here for use on the platform. We do a lot of work in background meteorology, background air pollution, plume sampling, ozone research, and this is just another tool in the toolbox for doing the research that we do. What we have here, I guess moving from front to back on it, is a variety of cameras and sensors. There's a high definition camera up at the front that's a standard GoPro. You can go down to your local Target store and buy it. We have a first-person view camera there that transmits the video that, or the view that this quadcopter actually sees down on the ground, so that I can watch on the ground what this is seeing from the air. There's a variety of sensors I put in here. Underneath the front, there's temperature and humidity. There's a pressure sensor over here. This white box is a data logger for recording all of the data down to a half-second intervals. Moving to the back, this is a particulate sampler. That's a new system that we are developing where you could go ahead and park this quadcopter in a plume, collect a sample, and then analyze it using optical microscopy or scanning electron microscopy. So it gives you the ability to sample both particulates as well as gases. This whole platform here is large enough so we can place different sensors, different instruments up on top. We have a couple of different ozone analyzers we run with this to collect data. We're in the process of developing the system for collecting VOC data using what they call sorbent tubes, where you just collect the air through the tubes and then analyze them afterwards. And it's a very versatile platform. When you get to the back, this is actually a GPS antenna and a compass, and that's used to stabilize the whole platform. So you could take this up to a given altitude, say park it at 300 feet, and now it'll stay within about a 10-foot box without having any other controls on it because it's controlled by the GPS. So it's a very stable platform. It'll remain airborne depending on the instrument package you put on it, anywhere from 10 minutes to 30 minutes, and it'll take up to about a 3-pound payload. This is the transmitter unit that's used for controlling the quadcopter. You got the various flight controls. There's a number of switches that are used to switch modes of operation for GPS control or just a simple attitude adjustment. The throttle and positioning controls are down in here. There's also a flight screen right here that gives you real-time information for both temperature, for flight parameters, for how long you've been running, how long you've been airborne. The switches that are used to control samplers are all over on the right side that are over here. Now when you go up to the actual display screen, this gives me a real-time display of what the quadcopter is seeing out the front, and that's out basically the front of the quadcopter on this side. Up in the upper left, this is essentially my gas gauge or my fuel gauge. It's all electric powered. It tells me what the flight battery voltage is. It gives me an idea of how much more runtime I have left on it. In the middle here is a pitch and roll that tells me what the wind is doing to this, how it's having to pitch into it, and that'll give me an idea of what the winds are up at loft. We also measure if you're moving in a forward motion, it'll calculate the velocity or your forward motion on it. The number of GPS satellites, and obviously indoors we don't have any GPS coverage. But that'll tell me how well the GPS has been locked on. You have rate of ascent and descent, and this tells me whether I'm ascending or descending and the rate at which I'm going. Over on the left side, we have, when you launch, you have an altitude that is calculated based on the time you launch. You have a distance from your launch point, so you always know how to get back to where you started. And in the bottom is a flight mode. Right now it's set for GPS mode, and that will basically let all of the positioning be controlled by GPS. And this can be set up in an autonomous mode where you can send a program and allow it to fly from point to point to point, all based on GPS. So everything you need to fly the quadcopter is all based on this system. This particular unit also has a telemetry control, so all of your flight parameters that are measured on the quadcopter are sent back to this flight controller and stored on a SD card. There's a memory card that has that. All your GPS positioning is recorded every 1/10 of a second. So now you have the ability to bring that back in, embed it on a Google map, and do all your analysis based on your X, Y, and Z position. Now, one of the things I've learned in the development of this is part of the driving force in being successful in getting a platform like this working is enthusiasm, understanding of what the sensors will do, what they won't do. And I've seen a lot of interest in this. There's a future, and this is really the future of doing airborne sampling. It gives a lot of advantages over being fixed on the ground or flying on a balloon, and it gives a lot of flexibility. And I think the challenges over the next year are going to be working with FAA to get their acceptance. And that is something that can't be taken lightly, and we're working very seriously on addressing those so that we can use this new technology. We can use the sensors that have been developed. We can use the data analysis processes that we've been working on in order to really turn this into the next generation of air sampling.